Hello, my dear students, and welcome back to a new lecture related to the renewable energy, the on-grid PV system on-grid course. And this is actually an extended lecture to our current playlist related to a complete design problem for an office building in Nairobi in Kenya. During this lecture, or maybe a series of videos in one lecture, we are going to discuss further or sequential steps we need to make in order to make a full energy management slash PV sizing for a building. We are going to start first with considering the word energy auditing and energy management, where we are going to make a reflection to uh, lighting loads in specific. Then, after load optimization, we are going to start our PV sizing process considering an on-grid system. And maybe in a later video, we are going to go with the off-grid solution and make a final comparison between the off-grid and the on-grid solution with respect to the grid utility tariff as a reference. So this will be a complete case study that you may use in order to investigate similar studies with similar types of buildings and actually with similar or maybe even different loads. So let's go into start share screen with considering this case, and this is typically what you can see the case we are going to study today. So as you can see in the head of the question here, we are going to start with a series of lighting loads that is all given. These are the loads considered for optimization. So these are the typical loads. As usual, I'm going to use Excel in order to solve this. And let me open the okay, let me open the Word version of this exam just to make the copy paste easier for the table to the Excel. Okay, so typically this is the first case, so I can copy this and put everything here in the Excel. So now I copy the table. As you can see here, these are the given loads. Okay, so as I mentioned in the beginning of the video, the first task is to optimize these loads. And if you return back to our energy auditing lecture, you will consider that we defined 3 levels of energy auditing, starting with what we can call the low level or level A of the energy auditing, related mainly to a zero cost actions that can effectively utilize resources. Going into level B, which is here proposed when you go to replacements. So here, as you can see, we are going to suggest some sort of alternatives to this lighting source. Here, what I mean the word alternative is that I'm providing a source that can have the same illumination, the same light intensity, the same lux, but with lower wattage. So, for example, if you compare this IP65S1 with 400 lux and 13 watt per unit, you can find that we have another alternative, which is an LED alternative with 400 lux and still 400 lux, but only 7 watt per unit. So here, what you can see is that we reduce 5 watt per unit with 27 unit replacement. But of course, here you have to consider the cost, and this we're going to talk about it here lower when you see it Each LED is with an average price of $0.3 per lux. So whenever you buy this one, you will pay per unit 400 times 0.3 to get each of these LED sources. That's why you have to consider this cost, and this what we are going to typically do in the next step. So first, what we are going to do is I'm going to make a comparison between each regional, or what we can call a current source working, and the alternatives available. And the word again, alternatives, is related to those lighting source with the same lux. So here we have, for example, only two, this one and this one. These two alternatives are given with the same lux. But as you can see, that this one is basically have a power which is greater than the one we have. So we got, without going into any sort of um, um, calculations, you can easily observe that it's not a good decision to go with this source, because typically its power is greater than the original power you're running. So the alternative source now is this source. We can substitute this one with this one. So how we can do this calculation? Let's see. So my alternative now, so here, let's go to this direction. So I need to replace this one with another one. So let me copy this. Put it here. As you can see, this is a proposed alternative. So the one in deep orange, this is the proposed, and this is in light orange is the one already running in the system. So how can I take a decision that this is an appropriate alternative for my case? Let's start with the first case, which is the one we already running with. If you go with the total power consumed by this device, this will be typically 27. I have a 27 unit, or I need 27 units multiplied by the power per unit, which is 13. And this number will be in what? Okay, so this is what I need for the wattage I needed here. Same apply. Okay, go here. You will find that the alternative I need is equals to the same quantity, which is 27, times the power, which is 7. Okay. Okay. So may one of you asking me about why you are considering power, not energy. Usually we are, whenever it's come to consumption, we should consider energy, and of course this is correct. But simply here, energy is just a direct multiplication with a number. I mean, if I choose alternative one, or if I choose alternative number two, in both cases, the number of working hours will be 16. So simply, the total energy consumed here is this number times 16, and the total energy consumed in the second one is this number times 16. So it doesn't matter if you make a comparison in terms of power or energy, because simply you have the same working hours. But when we go to level C of energy auditing to reduce the number of working hours here, we should by force consider the energy in our calculation. So this is the first point to consider. Okay, now we can see that by substituting. So here we can say that this is a saving in power. Still, the unit is what? Okay, so the saving in power is simply the subtraction between this number and this number, which is 162. So I'm saving a power of 162. I'm saving a power of 162 watt for this category or for this item. Now, the question is it worthable to take the decision or not? To answer this question about if it's worthable or not to consider this decision, we have to go to the economic part of the story. So what is the economic part of the story? The economic part of the story is simply how much money I'm going to save by making this decision and the cost of this decision. So in terms of money, you can simply calculate it because now you know that you are saving 162 watt. And you can simply say that, okay, to calculate the save the energy, and let's do it in kilowatt hour per day. So we can go to this number, which is the power, times the working hours, which is this number, over 1,000 to convert from watt to kilowatt. So this is typically what we need. Or what we save, I'm sorry. So we save about 2.59 kilowatt hour per day. Okay, so to come to the cost of this number, you have to use the turf or the electricity turf. And this, I think, is already given in your case. So if we go to the sheet here, you will find that somewhere I already mentioned to you that yes, here that the grid utility provide electricity to the residential with about $0.16 per kilowatt. So this is the price in Nairobi in Kenya, the capital of Kenya. This is the price per a single kilowatt hour. So in order to calculate the total power, sorry, the money saved per day, this money saved, so saving per day, I don't need to put equal, I'm sorry, saving per day, the unit will be dollar, will be simply equals to this number times the 0.16, which is gives this number. So I'm saving about $0.41 per day. Okay, again, this is a saving per day, but how can we decide or how can we consider that this is a good decision or not? This is an important point. So this is the saved amount of money per day. So to calculate the overall saving per year, then you can multiply this number times 365. So we are saving 151. You are saving $151 per year. Okay. So again, till now, it's not clear for us if this is an appropriate decision to make this replacement in terms of an energy management or not. So in order to consider this, in order to consider the decision, you have to make a reference. You have to make a comparison. What we have concluded that this lighting source saves $151 per year. But the question is it worthwhile to make the decision or not? In order to decide, you have to make consideration to the price of this lighting source. So back to our sheet, you will find that I told you that if you choose any of these alternatives, this table, you will find that each lighting source will cost $0.3 per lux, considering that the lifetime of these new LEDs is 2,500 hours, working hours. So now the price of this lighting source is $0.3 per lux, and we have a 400 lux system. So you can calculate now the total price. I will return back here. They put here the LED price. Of course, it's still in dollar, and this will be equals to 0.3 times this number, which is 400. So it's $120. This is a price. But again, so per year, I'm going to save money, which is greater than the price. But how many years is or are the expected lifetime for this lighting source? So to calculate the expected lifetime for this lighting source, so simply the lifetime will be this 2,500 divided by the expected working hour, which is 16. This ends up to roughly half a year. So as you can see, this is not an economic decision due to the very limited lifetime of this lighting source. Basically, if the lifetime of this lighting source is relatively higher, then the appropriate decision should be to change, because per year I'm going to save 150, and if the lifetime, for example, is 4 or 5 years, then I'm going to break even before the first year. So maybe with the third quarter, I'm going to break even the system. I'm going to make saving instead of losing money. However, due to the limited lifetime, as you can see here, it's working 16 days a day, 16 hours a day, I'm sorry. So for this 2,500, it only works for 156 days, which is less than half a year. So that means that after 6 months, I'm going to replace this lighting source. And of course, this is not an economic solution. So this is an example how you can select your alternative. It's a matter of cost, saving, and lifetime. So by these combinations, you can choose the appropriate decision. So based on this procedure, you can keep on discussing the alternatives that are provided by this other sources, as you can see. So per source, you can go to check which alternative is available in terms of the same lux, and then we can discuss the possibility or the visibility of choosing this alternative with respect to, as I mentioned, the power saving, the energy saving, the cost of replacement, and the lifetime. And based on that, you can make your decision. In the next part, I'm going to start sizing the load based on what we can call between quotation the optimum consideration. And then we can start together the process of PV sizing optimization.